Hi everybody, welcome back. We are now going to talk about graphing rational functions. And there is a procedure to this. This is kind of a simplified version of something I've used in the past because this will handle most of the basic types. There are some more complicated ones where you have to add a few steps, but we're not going to handle that in this course. So basically the idea here is, well, y-intercept's usually a fairly easy thing to find, and there's only one of them. So if you can find it, find it. Then you're going to start off by finding the horizontal asymptotes or any other types that may exist. Then you're going to factor the numerator and denominator completely, and then this will help you more easily find the vertical asymptotes, because if you have a factorization in the denominator, instead of equal to 0, you just break apart all the factors and solve all the simpler equations. Then we have two steps. We have to find the zeros of the numerator and the zeros of the denominator. You notice that the zeros of the numerator and their multiplicities, so that's important because we need to know their multiplicities as well. And the multiplicities will tell us for the numerators about crossing bouncing behavior on the x-axis. But, and this is not very commonly taught, but this is kind of a trick I show students, so that the zeros of the denominator and their multiplicities talk about crossing and bouncing at affinity. So we'll see that when we do the examples. So here, I'm looking for the graph of x over x squared plus 1. So there is a y-intercept. You just, that's easy to find. So if we let 0 equals x over x squared minus 1, well, the only thing that will make this 0 is x equals 0. So the point 0, 0 is the y-intercept. Alright, so now we want to find horizontal asymptotes, or other types of asymptotes. So we compared the degree of the numerator to the degree of the denominator, so I'll zoom in a little bit here. So we look at the pairs, and we notice that the degree of the numerator is less than the degree of the denominator. So this means that we have a horizontal asymptote, and that is y equals 0. We have the horizontal asymptote y equals 0. So now we need to completely factor this. So if we completely factor this, well, the numerator is completely factored, so we'll just get x minus 1, x plus 1 in the denominator from factoring a difference of squares. So our vertical asymptotes correspond to the zeros. So we'll get x equals 1 and x equals negative 1. And then, let me see, let's zoom in a little here, or zoom out a little so we can keep all the information on the one page. So now we have to find the zeros of the numerator and denominator. So for the numerator, we have x equals 0 with multiplicity 1. For the denominator, we have x equals 1 with multiplicity 1. So I'm just going to put mult for multiplicity. And x equals negative 1, which also has multiplicity 1. And then plot any additional points. We'll see if we need any additional points at that time. Usually with this method you don't need additional points, but occasionally it happens, and then we'll draw the graph. So let's look at, let me see, do I have room down here? I have room down here. So let's keep all this information here and put in our grid. So there we go. So I want to draw this in black all the way down here. And let's just put in our information. Well, our y-intercept is 0, 0, so we know this is a point on the graph. We know we have a horizontal asymptote at y equals 0, so I will draw asymptotes in red here. So we'll have an asymptote. And notice that the point 0, 0 is on the asymptote, which is allowed. These functions are allowed to cross horizontal asymptotes, but never vertical. Let's make this -1 and this 1. So our vertical asymptotes look like this. So now we have to figure out what to do with these. So unfortunately, we don't have a sense of what's going on here, 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 or here. And while we know we cross at x equals 0, we don't know if we cross like this or we cross like this. So we need to figure that information out, so we need to plot points. So what I'm going to do is I'm going to figure out what f of 2 is. Because f of 2 is going to completely determine everything else that's going to go on. Well, actually that's not true. You pick x value either from this region, or this region, and that will completely determine it. And I'm just going to pick 2 because it's positive and an easy number to plug in. But that's not necessarily a unique choice. So let's see what f of 2 is. So f of 2 is going to be 2 over 2 squared minus 1, so this will be 2/3. So when we're at x equals 2, we will be right about here. Now this tells me a lot of information. One is that as we get this going in this direction, we are not going to cross the x-axis again, because if we were going to cross the x-axis again, we would have another 0. And since we only had 1, 0, which is x equals 0, we are never going to touch the x-intercept. We're not going to touch the x-axis again, so we know that we are going to approach the horizontal asymptote here at x equals 0, but never reach it. So let's change our scale here for a little tick here. So this will be still 2, but let's make this 1 here, so I can draw this a little nicer. So 2/3 then would be right about here, and we'll draw it like this. And now we know that at x equals 1 for the denominator, we are going to have a multiplicity 1, and this is where we're going to talk about crossing at affinity. So what this is going to do is this function is going to come up here and go towards positive affinity, because it can't go towards negative affinity because it would have to cross the x-axis. And when it gets up here to affinity, wherever affinity is, it's going to jump to the other side of the equation, or the other side of the asymptote. And then it's going to cross here at x equals 0 because the multiplicity was 1 at x equals 0. And again, we're going to keep on going and approach positive affinity again. And because we have a multiplicity of 1 here, we are going to get to affinity and jump to the other side and continue graphing. And basically, going to finish the graph off like that. And we know it doesn't cross the x-axis again, because again we would have another 0 when we look at our zeros of the numerator. And since we only have 1, 0, we know we'll never cross again. So this is going to have to curve and keep going to the left, but always approaching the x-axis, but never quite getting there. So this is the graph of the curve.